All right, let's get this going. We're live. So, Roger, hi. Thanks for
Hi.
spending the last hour with me before
No,
this
no
podcast.
problem.
This is going to be a conversation to dive deeper into Picterra. And we actually heard about Picterra through a alumni, or actually a student who was actually in our program in 2019, like during the summer. And she was working on developing solutions for her city, and she was researching opportunities to connect with it, using a tool basically to do aerial analysis, right? And she she popped up Picterra, and so that's how we found out about it. And then we encouraged Rahaf to essentially engage Picterra, and she did. And then out comes Frank. But I think there was a woman that she connected with before Frank that connected us to Frank. So that's really exciting.
Perhaps that was Monica, our
Was it
marketing
Monica?
person.
It could have
Maybe.
been. It might have been actually. I'm gonna dig in on Rahaf and see if who the name was again. But it was really kind of serendipitous because she essentially reached out to somebody at Picterra. They responded, and then we got Picterra in a article locally, and so it was mentioned. And so Rahaf sent it, being a good marketer, send it to somebody in marketing at Picterra. And so that's where the opportunity came in. I was like, hey, we gotta get this, let's see what these kids can do more of. So, and then working with Frank was really cool to work with because first of all, you were in another country, right?
Mhm.
And so that kind of brings us a use case of a global employer. And then also, I got to know Frank because he came out of San Francisco, and we actually sat down and had a chat at a coffee shop. So I got to meet a global employer locally, right, while he was on a conference, and also
Mhm.
Picterra is a cool platform, and he was really into it when we got involved. So I'm excited that we're starting to have more people, like from Picterra team, at least aware of what our program is and being involved. So thanks for being here.
Well, glad to be here. And perhaps I'm not so as international as Frank is, but I'm actually from. I lived in San Francisco for 2 years actually, so I'm not quite
Oh,
as
okay.
exotic as Frank is, but
And I think that's a perfect liaison, right? Because you can the culture here, locally, and then you're working over there, so it actually just works out perfectly, frankly. So our program's about to get started in about a month, and we're working with Picterra again. Excited about the platform, excited about the new scope of our project. When we went to our program last year, we were going in partnership with City of Hayward, and then the pandemic happened, and then we spawned Picterra out with its own as an own their own your own employer. And then it was successful for the most part, and then students got in internships or fellowships, we called it, and then they built solutions. And so this year, we have this really particular scope that's exciting. So let's get started with just a bit about you. I know you came from the local area here, and that's actually good. Will be a fun story to dive into. So kind of go back into the high school days. What kind of kid were you when it came to understanding your career paths, and even if you knew what that was, and how did you go through your college journey or your journey post secondary into where you're at now?
yeah, actually, so my high school was spent on the East Coast in Farmington, Connecticut. So my high school was Farmington High School, and back then I think the most defining thing for me was the robotics team. And I'm not sure you guys still have this in the U.S., but there's this program called FIRST, and I
First
guess
robotics.
yeah, exactly. I guess there's
Mhm.
probably some parallels with what you guys do at Pilot City, but basically involving high school students in sort of this yearly, it's more of a competition, I suppose, where you build these 5 foot tall robots, and you basically have them compete in some kind of sport like competition. So like throwing a ball around or scoring it. So like not BattleBot style. Um, and yeah, that really got me into the more technical side of things. So I myself actually am a software engineer with some specialties in machine learning, and the robotics team was really what got me into that. Because I believe my second or third year, I started doing a lot of like autonomous software engineering for the robot, and it was really simple stuff, like drive forwards for like 10 seconds. I think I remember once I accidentally put an extra zero in there and had the robot drive forward for 100
Spin down.
seconds, ran straight up a wall and flipped over in the first 10 seconds of the match. But
Great learning
anyways,
experience.
I've gotten better since then, hopefully. But yeah, so that really got me introduced into my career path of computer science, software engineering. And then from that, I went to Brown University.
Actually, let's pause there for a quick.
Yep.
So, you had a technical experience, in high school that you really enjoyed. Like, how impactful did that end up becoming? I guess you'll tell that story, but like.
Yeah, I think that was probably my first like major defining event in my career path, because really, like, I remember we had this big warehouse and to build the robot, of course, and every day I would be there until like 10 or 11 p.m. just working on the robot, designing things from scratch. It was really free form, learning a lot of new skills. And I remember that was one of the first times I was like, oh God, like I don't have to do like doing homework was definitely a drag for me in high school, as it is for all students and for most students. But I remember I could just be at the warehouse working on this stuff until late hours of the night, and I wouldn't even notice time go by. And so
Love it.
to me, that was a clear sign that this was sort of the path I wanted to go down.
That's one of the questions that we ask in our interview about 2 years ago. We kind of phased it out, but it's definitely a valid question still, is what thing do you do where you do it and you just lose time doing it? You didn't even know time went by,
Hmm.
because it means that you really kind of, can geek out on it and enjoy it a lot, right?
Yeah, absolutely. Yeah.
Great. So great. So feel free to, yeah, how did that inspire your entrance into Brown University, or kind of what you ended up studying and so forth?
Yeah, so I really got into more of the whole software engineering thing, and from that I was a bit like, okay, well, it looks like computer science is the way to go. And so then I went to Brown University, which has a pretty good computer science department, so that's why I chose it. And also, just the general the atmosphere to me was kind of let's say a bit more relaxed than something like a pure tech school. So I thought it was a good fit for me.
So you have some
So
options, it sound like.
yeah, a few. I'm not trying to
Okay.
boast here. Yeah,
Yeah.
yeah. I applied to all the ones that the classic group that any proper Asian parent wants their child to apply to in the U.S.
Oh, there you go. See, yep, there it is.
Yeah. Yeah. So yeah, I actually at Brown University, I did not do robotics in the end. I sort of discovered that the hardware itself was not something that I was particularly interested in. Like, I enjoyed working on the mechanical aspect of things, but when it came down to things like electronics, to me that was less interesting and sometimes quite frustrating.
Yep.
And I found myself really gravitating more towards just like coding. And so actually in undergrad, I was focusing a bit more on computer graphics, which was a lot of like mathy computer science, basically like creating like rendering engines and all that, and all the different illumination equations, and how to do like global lighting versus local lighting, et cetera, et cetera. And so that kind of gave me sort of a background that was not pure mathy, but semi-mathy, and also very software engineering intensive as well. And so, yeah, 4 years of that went by, and it was a great experience as well.
So
And
you really got in. So you discovered midway. Well, it's interesting because it's the evolution of someone's definition of themselves and what they care about, right? Like
mhm,
you really geeked out on this robotics thing because it was an integration of all these concepts and applied learning, and you're actually doing stuff and you're like, oh my god, I can't believe this is school, right, type of thing. And
mhm,
then you go into the college saying, hey, like I want to do something, around robotics or hardware or whatnot, and you tried that, but then you ended up gravitating towards just the software piece, and then you started looking at images too, which is kind of like more of the graphic side of things.
mhm, absolutely, yeah.
That's great. Like did you see that as a pretty fluid sequence of evolution, or was
It
there any
it
battle with
definitely
your parents or something like that on which one to
no
do?
no
They're
I
both
think
technical,
as
so
yeah as soon as I got into into software stuff, I think they're like, okay, he's on a good track and
yeah.
no more worries. So
I
but
think like what's interesting is that software also is much more malleable and flexible, and you can have more opportunities in different places,
that's
including
right.
hardware, right? So
and
it's
and that was definitely a major motivation for me for shifting away a bit from robotics, and not past just like the difficulties of working with like physical electronics and stuff. It was also just I realized that there was a lot of opportunity in software to do things that could be applied to very like a lot of different domains, perhaps. And so that really inspired me to more go towards that like coding, software engineering type of application. And the graphics to me was like I kind of had a slight more focus on that because it was just visually fun for me to look at my results, to see how like things appear on the screen when you like implement a new equation or something. Um,
and
and
that's
in
a
fact,
and that's a very good dovetail on what you're doing now, right?
yeah, actually, it makes a ton of sense. Actually, I took a computer vision class my senior year, which is getting actually back then. Machine learning wasn't a huge part of computer vision yet. Looking back, it's quite amazing.
Mm,
I'll get into this a bit later, I suppose. But like
sure.
nowadays, you have to do machine learning if you're doing computer vision. Otherwise, it's a bit like what are you doing? But back then, when I took that class, it was there was no actually no data involved. It was sort of these hard coded algorithms. But I still enjoyed it nonetheless. The fact that you can sort of gain meaning and insights out of a 2D static image,
Mm,
that in itself was fascinating to me.
mm, mm,
Um, yeah, in the end, I actually before Picterra, I worked at Apple for 3 years
mm.
as a pure software engineer, and well, at first they told me I was going to be working on some graphic stuff, and I so that was a bit the motivation for me
Misleading.
going there. I was like,
Mm,
all right, I'll go work at Apple. It's a good name, make my parents happy,
yeah, yeah.
and also work on some graphics. I ended up stopped working on graphics after 6 months. Then I got changed into working on like the WebKit framework,
Oh, okay.
which is the rendering engine behind Safari, and so
Mm,
still loosely tied to graphics in some way.
mm-hmm.
Um, and I was pretty content there for quite some time, maybe 2 or 3 years. But at some point, I kind of realized I wanted a bit more. Like I started reading all these articles about machine learning and how they got applied to computer vision, and that kind of reminded me of this computer vision class I took back in Brown. And I was like, I really want to get back into that, and so I kind of started, just very casually looking at different universities and seeing the different programs available. And the more I did it over time, this idea sort of started to sprout in my head, to grow more and more.
Mm,
Um, and yeah, then I was just at some point got pretty serious about like looking at schools, and I asked if I was in San Francisco, and for some reason I had a ton of French friends in San Francisco, and I just asked one of them like, "Hey, is there by any chance any school that could apply to in Europe?" I wasn't being too serious back then, but then he listed off a ton of them, and some of them I found had actually really good programs, and they were still mostly in English. So I was like, okay, this is definitely a possibility. Oh, and they were free, so that was also a major advantage, and that's how I ended up going to EPFL, École Polytechnique Fédérale de Lausanne in Switzerland. And I
yeah.
did a 2.5 year master's focusing more on machine learning and computer vision. So really, but more, yeah, so more getting into things like deep learning and like newer methods, basically. Uh, yeah.
So I missed a step because there was a bit of lag, but so you somehow you decided to go you decided to go overseas at some point
Yep. Yep.
to do this masters. Okay, got it.
Yep. Yeah. It's well, besides the department being being a good department for in terms of computer vision and machine learning and computer science.
Mm.
Also, my tuition was 600 francs a semester, And so the other options that I got into for my master's program in the U.S. were Georgia Tech and UPenn,
Ooh, oh yeah. Ooh,
and they were like, ooh, they were still like 20K or something per semester, you know. So
geez, yeah.
uh, yeah, it was a bit like travel experience
Hmm.
and good program and cheap tuition. It hits all the check marks, you know. So
Okay. And you're there now? Are you still there? Are you
yeah,
remote?
I've been here 5 years now, pretty much. Yeah,
Wow.
I've been working at Picterra for almost 3 years now. Yeah.
Yeah, phenomenal. Okay. That's a very interesting pathway that you've taken. And I think you've checked all the boxes at least on the family side, and then I'm sure you've also you finally itched kind of the kind of the machine learning aspect, the graphic kind of analysis kind of aspect of things too, which is
Yep,
great.
absolutely.
So it sounds like you're pretty much on like cloud nine at the moment, just experiencing life at this point, right?
Yeah, absolutely. Especially right now, working at a startup, it's such a different experience than working at a major corporation.
Apple.
Yeah,
Yeah.
I feel like my main role is to do this computer vision, machine learning stuff, which I love. But at the same time, I also get the opportunity to do a ton of other things. I write a lot of Medium articles.
Mm.
I do a lot of different like webinars and marketing stuff. Sometimes I talk to clients to do sales. It's really, I at a
Wonderful.
startup you do what's needed, so you get exposure to almost every aspect of a company, which is great.
Yeah, and you're part of the first, first seven, first 10, I believe, right? So,
Yeah, the second employee after the lead engineer. Yeah.
ooh, nice, nice,
So
nice, cool. So let's get into Picterra. Like, give us, you got into Picterra, met these French folks, you got to you got to a graduate school over there, and then you started looking for gigs, and then you found Picterra. And so what made you gravitate towards it specifically, and what were you looking to learn, and then give us a little background on Picterra and what Picterra does.
mhm. So actually, I met Picterra through my master's thesis. So yeah, I guess it's true for any program, but my master's program I had to do a 6-month master's thesis at the end, and I was basically looking for anything involving computer vision, so machine learning on imagery. And at the time, I was also a bit motivated to do something that was kind of related to space stuff,
Mm.
uh, and also something that was very a young company, a startup. And so once you add all these different filters,
Yeah.
the pool starts to shrink quite a bit.
Yeah.
Uh, and so in the end, I interviewed with a few different places. Like there was one place I interviewed with, which was doing like computer vision for like mapping all the streets of the UK for like autonomous driving.
Mm.
And then there was also one that was like using computer vision for NBA coaches to like
Interesting.
to do like statistics on their players and to optimize how they're like taking their shots and stuff.
Oh, okay.
Yeah. um, those and both of those were one of them was in Switzerland. I wasn't as interested in the NBA one. I used to follow NBA a bit, but I wouldn't say it was my 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 major sport
Yeah.
following. And then the other one was in the UK, the autonomous car one. And in the end, I chose to do Picterra because the whole satellite thing really kind of resonated with me. And of course, as I'll explain later, we don't just do satellite, but satellite imagery is a big part of what we do. And that part resonated with me quite a bit. And I also got the chance to stay here. And I just started seeing someone at that time here, so I had a bit more motivation to stay in the area as well. So
That'll
yeah,
help.
that kind of yeah sealed the deal there.
Nice. Okay. That's exciting. And just what I found after working with more software engineers is that typically their life is also almost like an algorithm, right? Like you come to a point where you make really good decisions
Yeah.
because it's logical, right? And it makes
Yeah.
sense. So
No,
the
you're
options ended up becoming pretty pretty good on
That's
your
right.
front on all angles, right? Personal and
Hmm.
professional.
Yeah, it
So
does. I oftentimes tell myself there's like different pillars in life to satisfy. There's, like the social one, the intellectual one, the emotional one, and then like the physical health one. And as you're exactly right on the money though. Like I feel like it's because of software engineering and computer science. I tend to like think this way of like, okay, how many buckets am I satisfying, and how do I really optimize, my like my enjoyment in life in some way.
jeez,
Yeah.
I
It's a
don't
bit
know if
too
I
much
feel
maybe.
bad for you or
Uh,
if
it's
I like it as
it's
well.
not something I think of like constantly, but it's like I usually just play it by ear. But occasionally I'll be like, oh yeah, like it does fit all these bills. I am doing great. So
So there's a I don't know if you've heard of Ikigai. It's Ikigai. We don't do this thing where we screen share on here just yet, but I want to start getting into it. But I would screen share for you. But it's basically a Japanese kind of approach for life and discovering purpose. And it's basically a Venn diagram of 4 items that then reach your Ikigai, and essentially it identifies what are you good at, right? And then what are you good at? What do you love doing? And then what does the world need? And then what can get paid for? So it's those 4 things coming together. And I feel like that's a perspective of kind of what you're deciphering. And I like this model because, a lot of young people, I think that what you love is number one, right? Like
mhm.
just going through the passion, of spending the time in the warehouse just tinkering along and just losing time, right? Like that level of energy that gets provided when you love something is so exciting, and you just want to do it all the time, right? And then there's the
Mhm.
thing that you're good at, right? So you not necessarily, you don't actually love it, but you're good at it, so it's easy, right? So it's like, oh, I'm just gonna keep running because it's easy for me to run. Like I don't actually like running at all, but like there's things that people are good at, and they can do it forever. Well, not forever, it's just easy, so it's just like, okay, I'll do it, sure, no problem, right? And it's just
Mhm.
like something you're good at. And then what's interesting is the thing that's outside of you, which is, what does the world need? What does your local community need? What do other people need besides me? Like, I know I love this, I know I'm good at this, but what do you need, right? That's an interesting kind of exploration of a career pathway. And then what's interesting is the way you can get paid for aspect, right?
Mhm.
Because not everything that you love you can get paid for. Not everything that
Yeah.
you're good at you get paid for. Not everything
Mhm.
that the world needs can you necessarily get paid for. But all that together is almost like I feel like that's been my big mission, right? Like this is actually the logo of my old clothing brand called Myth, and it's about pursuing the unknown. Just go towards where you want to go, and see where that goes. And hopefully you're factoring all these different pieces of what you want, in life, so that you pursue
Mhm.
you get to where you want, or love it as you get there, right?
That's interesting. This four circle model you're talking about. I think there's one thing I feel like that I don't fully agree with, which is the what you're good at part of it. Because I feel
Mm,
like maybe back in the day, your options were a bit more limited in terms of what path you could choose, what you could really specialize in. But I feel like in modern society, there's this, at least in more privileged areas of the world, there's so much opportunity to go down whatever path you want and learn whatever you want, that if you really put your mind on something that you might not be good at now, it seems like you have the opportunity to become good at it later. So
yep.
uh, to me, it ends up being more of the uh, replacing that part of the Venn diagram with what are you willing to put the work into getting good at,
Oh,
rather than
interesting.
what you are just good at.
Well, that's a very interesting perspective. I'm a big fan of the Gallup Strengths Finder test, which is basically like a $20 test by Gallup that you take, and then you spend 30 minutes doing it, and then it pops out your top 5 strengths, and then it categorizes all the strengths, which is 34, and it puts it in order essentially, and they give you your top 5. If you pay 80, $90, you get all of it, type of thing. And it identified that supposedly I'm an ideator, supposedly I'm an activator, supposedly I'm restorative, supposedly I'm futuristic, and supposedly I'm strategic, right? And so what's interesting about those is that it allowed to see that allowed me to say, okay, these are, I guess, what things I'm good at. And so if I agree with it, that allows me to double down on those things or to triple down on those things or even, 5x on those things or 10x on those things.
Hmm.
And I feel like that allowed me to be able to kind of go out and actually pursue what I want to pursue with confidence. Right.
Hmm. That's true.
And
Yep.
now I totally, I don't, I also I agree with you in the sense that I don't think that we should I don't think that we should ignore our weaknesses, right? Especially if we believe it's a potential strength, right?
Hmm.
And so I feel like it's kind of one of those
Yeah,
things,
it's
right?
maybe the
Um,
potential strength is the thing.
yeah,
Yeah.
there you go.
It's
I
like
think
what?
it's potential strength.
Yeah. Yeah.
What things that you might be good at? How about that? For the
Yes.
Ikigai, yeah, things that discover things that you might be good at that you haven't known yet.
All right. I can agree on the terminology.
Yeah. Okay. All right. So Picterra,
Hmm.
describe just in your perspective, what is it? What are you guys building over there?
All right. Well, I guess I've given this pitch a ton of times already. So,
Yeah. You're a seller,
um,
you're a Medium blog poster,
yeah, yeah, yeah. I'll try to give it a
developer.
bit less of a medium article swing to it.
Sure.
But yeah, so basically, the way we see it, there's sort of these two major. Well, first and foremost, we're a technology company, and we're basically a software as a service. So we have an online platform that you can log on to, and from there you do everything in the browser. And so Picterra's technology really sits sort of at the intersection of two other technologies, and that is the geospatial domain, which is Earth observation imagery. It's basically data that you get from the sky or space. Um, and the two co-founders, Pierre and Frank, both came from this domain, and so that kind of inspired entry into that particular part of things. And they also came to the realization that machine learning was also becoming a huge thing at the same time, especially machine learning on imagery. In fact, so earlier I was saying that when I took this course at Brown, that was in 2012, about computer vision, there was no machine learning in there yet. And it was literally that year that the first paper came out that used deep learning, which is a type of machine learning on imagery. And so basically, there's this bit of context. There's this challenge online called ImageNet, and ImageNet is this challenge composed of billions of images and thousands of different classes of images. So like cats, dogs, cars, boats, you name it, 1,000 different categories. And the idea is to feed each of these images into a computer vision model and have it determine what category the image belongs to. And so pre 2012, let's just say that the accuracy was not so good. Maybe it was like a 50% or something, So it was a human did way better, right? In 2012, someone started using deep learning on this stuff, actually bring machine learning and data into the pipeline. And previous to this, the accuracy had sort of been increasing year by year, like 1 or 2% or something. Someone made a new little discovery here and there to boost the score. And this machine learning thing brought the score up by about 20% in one paper. It just went bam, like huge jump. And ever since then, the performance on this particular challenge and a bunch of other ones has just been exploding. Like CVPR, which is the major computer vision conference that happens every year, it's an international thing. Let's just say that before 2012, if you did a paper on computer vision using deep learning, you probably would have been disregarded and your paper would have been rejected. Post 2012, if you don't use deep learning, people will ignore you. It's like the exact opposite. So it's crazy. There's really a huge explosion, and definitely research is still continuing in that field. And so I guess the to bring it back to Picterra, Frank kind of realized this and wanted to bring machine learning and computer vision, the deep learning form of it, to geospatial imagery. And there are other companies, like when we first started, there were other companies that were already doing this, but typically they took the form of consultancies. So they were basically consultants that worked on projects that required machine learning on imagery. And what we wanted to do, our main vision was to democratize this, to make it so that anyone, even people who aren't machine learning engineers, basically the end users, could themselves use the platform and apply machine learning to geospatial and Earth observation imagery. And so, yeah, that was the vision. I guess the ultra long-term vision was to become the Google search engine of the physical world. So that's the kind of the thing the thing you sell to investors, I guess. But of course, that doing something like that requires an absurd amount of data, like you can't even believe. But one step at a time. So we're working our way towards there slowly but surely. And basically our transition towards that is to start with a platform where at least users can build their own machine learning models on our platform to search for stuff on geospatial imagery in a way that they can do it intuitively and create a machine learning model just by clicking on their screen rather than coding up stuff in PyTorch.
Wow. Okay. So one thing that I had a lot of questions in there, and I think the number one thing would be, well, I'd like to ask, I guess the first question, like, just for deep learning purposes, the word deep learning, right? So there's gonna be a bunch of students who are in high school who don't even know what software engineering is, right? So connect the dots real quick on how computer science, software engineering connect to machine learning, deep learning. How do people get to that outer space of software engineering, right? Deep learning and machine learning, and all these AI, like, what's the direct connection to connect those two thoughts?
Okay, well, I guess so. Software engineering is about creating a solution for something that runs on your computer. Basically, you write some code, and this code it's basically like something that you can give some kind of input and it gives out some kind of output, basically, right? That's sort of coding in a very simplified, raw sense in some way. Machine learning takes it one step further. So machine learning is basically learning how to transform an input to an output using data. And what that means is that, well, the analogy I like to use for machine learning is it's basically like you're trying to say you're raising a baby from scratch and they have no knowledge of the world. How do you get it to learn to do things? Well, basically you give it, you say you hold up an apple and then you say, this is an apple. So baby is like, okay, fine, that's an apple. Next, you hold up an orange, and then baby is like, this is an apple as well. And you're like, no, that's an orange, And you do that for all the different fruits over and over again. And with all this data, this input, which is the fruit, and then the output, which is the answer, so orange or apple. With enough of these data pairs, the baby learns, okay, the next time you give it an apple, it's going to be like, okay, I know what that is now. It's an apple. And so that's really the core foundation behind machine learning. It's basically using data to teach a model to do the right thing. And so now bringing this to deep learning, what's all the stuff in between the input and output? What is the thing that is changing in the baby's mind that's letting it learn that this is an apple or this is an orange? And this comes down to more technical details. So you teach a deep learning model in the same way that you would teach most other machine learning models. You still have this, this is an apple, this is an orange, that type of thing. But it's the implementation of how the baby is learning inside that thing that differs. And deep learning is otherwise known as, can be known as neural networks. And so the reason this is that it's loosely modeled after the way that our brains works. It's basically a structure, a logical structure that's composed of a bunch of tiny little building blocks. And each of these little building blocks can do a very simple operation on something. Say like, if you give it a picture of an apple, one part of the neural network will operate on one pixel of that picture, and another part will operate on the next part of that picture. And then you have another set of these. So each of these building blocks, let's call them neurons. And you have one set, say, that is just taking the raw input of the image and doing some kind of processing to it. Then you have another set that takes the processed versions of the image, and then it processes those. And another set that processes the processed versions, et cetera, et cetera, et cetera, until finally it manages to learn a very complex understanding of what an apple is. And
Yes.
it's a kind of vague.
Wow. Yeah. Well, no, it's actually biological.
Yeah, it's how our brains work, basically. You know, they transform visual inputs into a different understanding that our brains can really turn into something conceptual. In fact, so these neural networks are made of. I'm going to ramble now, but these neural networks are made of.
This is where your excitement
basically
comes in.
Yeah, now you can see my eyes light up. You know, I like talking about this stuff.
Actually, I have a question for you.
Yes.
Do you have light over there? I mean, it sounds kind of cool.
Sorry, yeah,
it's kind of cool that you're in this like outer space. You know.
Yeah, it got dark as we were talking. 1 second, let me just turn on the lights.
Sure, no problem. Great. All right, that helps. That helps. Yeah.
All right.
Yeah. Now we have
Cool.
some light in our space. It's good for it. Deep learning.
Deep learning. Yeah. So I was saying that basically, if you look at a drawing of what a neural network looks like, there's basically one layer of neurons that connects to another layer of neurons that connects to another layer of neurons. And basically each of these layers represents sort of a transformation on your original input. And it's basically boiling it down from the raw data, so like the red, green, blue values of the image, into something more conceptual and understandable, like at the deep layers. So maybe like, I don't know, like 50 of these layers down the road, you'll get to a layer that understands the image as something being like, say for a cat, it's fuzzy, it has eyes and ears. It's not like this pixel is red and this pixel is a bit more green anymore. It's really like conceptual data points. And so that's really the power of deep learning, is that our brains work this way too. You know, when we see a cat, we're not like, oh yeah, okay, like the ear looks like it's like 1 millimeter away from here, and then it's like, we don't work in these like little minute details of what is of what we see, right? We see things in conceptually, basically. And we see that the cat is fuzzy, it has ears, it's got a cute face, you know.
Yeah.
And that's what a deep learning model essentially is trying to learn.
Wow. Okay. So what's interesting is that let's go into the discussion around Picterra and how that translates to Picterra. So give us a translation of what you just said, right? And how now it applies to Picterra and what you're doing with deep learning. And
so on the Picterra platform, sorry, you're cutting off a bit.
Yeah, I know.
Okay, yes. So basically what Picterra lets you do is it lets you upload an image, except instead of a cat, it's some kind of aerial imagery from a drone or a satellite or whatever. And the idea is that, say you are looking for cars on this image of your city. What you would then do is, in Picterra, you would just annotate, and by annotate, I mean use your mouse just to outline cars. And you don't have to outline all of them. You can outline just a small subset of them. Basically, the idea is that you need to provide the information to teach a deep learning model of what a car looks like in your city. And so that's what you're doing just by doing this little drawing thing. And it depends on your application, but typically you don't have to draw like an absurd amount of cars to get started. You know, like there's there's one project that like we managed to detect something called slurry tanks across all of Denmark, the whole country, with only 56 drawings of a circle.
Huh.
So that was, it really depends on the use case, but it's usually not like people when they oftentimes they think of deep learning, they think about like, oh, you're gonna need like tens and thousands of data points in order to make this work, and oftentimes that's not true, and that's also one of the major motivations behind Picterra is that because we believe that that's not necessarily true for all use cases, it does lend itself to this sort of user interactive style of creating your own deep learning models just by drawing stuff because it becomes feasible to do that. And so going
And what
back
do
to
you
the
mean
car
by
now,
drawing stuff? You mean taking aerial images into Picterra and actually drawing, like scoping out what you want to process on the image, right? So what you
yeah,
mean
exactly.
drawing?
So it's like so give you a little preview of what the process looks like, I guess. If you have a large image of your city, you would select some small subregion of it where you see there are cars. And then you're like, okay, I'm going to use this subregion to teach my machine learning model what cars look like. And then you basically click on the annotating tool and you outline the cars. And by outlining them, you're basically telling the model, okay, the things underneath my outline, this is what a car looks like.
Mm-hmm.
And then all you have to do is hit the train button, and the deep learning model is not something that you have to be aware of on the platform. It's something that trains on our Google Cloud servers. And so you hit train, and all this information gets uploaded to the Google Cloud servers. It trains this deep learning model so that you don't have to deal with all of the machine learning aspect of things. And once it's done training, well, then you have basically this baby that is able to
Yeah.
detect cars in your city. And that's
That
basically
is
the
so
gist of
cool,
it.
dude. Like, I think when, because like, well, first of all, you perfectly explained everything, right? Like in the perspective that a person who doesn't know, what you're talking about, now knows, right? And the more exciting thing now is that you have this tool that's easily usable and accessible by high school students,
Mm-hmm.
really, that you can, and all you need is data, right, to feed it in,
Yes.
and then it'll run all the different pieces that it needs inside internally to
Mm-hmm.
process that car, that apple, that orange, so that the baby, or this kind of machine learning algorithm, or deep learning model, can process to then break it down, and then it just gets better and better and better,
That's
right?
right. Yep.
And so what's interesting is that, going to this kind of investor pitch, kind of vision, right?
Mm-hmm.
Of seeing the whole, having the whole earth be, mapped out and evaluated and assessed through just images, right? Because, photogrammetry is also something that I feel like is getting bigger, where people are just 3D scanning things, and we're getting more 3D model on real space, right? And
Mm-hmm.
so what we're talking about here is almost a pre-step to that, even, right, where we're essentially scanning the entire earth of all its objects, and it's not even, I mean, yeah, I guess our objects, right, of some sort, but it's more broad than that. It's flora, it's land, it's swaths, it's cities, it's,
It's
it's like,
really everything you can see, basically.
yeah,
So.
it's kind of ridiculous what
Mm-hmm.
mission you're on, really, right? But
Mm-hmm.
it's very doable, because you can train a leaf if you have the right image, and if you get enough of them, right, to train it. So this idea of mapping out the entire earth, and then know what all the assets are, because the deep learning model is identifying that it's a fuzzy tree, it's a fuzzy green tree in Africa, or in America, or in, Europe, or whatnot, or Asia, right?
Mm-hmm.
That's super exciting. Now, all that needs is data and people being able to actually feed it, right?
Mm-hmm.
So, are you gonna, what's the vision there? Are we just gonna, do we just have better satellites that take better images? Do we need people with more drones? Do we, how do you strap on, stuff on people and then let them fly everywhere and map everything? How do you get to that level of data?
So this was actually so. First of all, there is actually a lot of data out there already, especially for satellites. The and also drones are kind of I'm sure you know about the drone hype. Everyone is into drones these days, And so drone imagery is also becoming more widely available as well. And so that was also one of the strategic bets that we made as a company, is that this resource of aerial and satellite imagery was going to be something that would explode in the next decade or so. And certainly we're always talking to companies that themselves produce satellites and produce like satellites that take pictures from space with different sensor types, not even just RGB. Sometimes there are things like SAR radar data, which is this cool kind of data that can actually see through clouds. So you don't have to worry about which, yeah, clouds are a major problem in satellite imagery, by the way. But
The business to Picterra. Clouds are enemy.
yes, they are. Yeah, that's a side story. I'll talk about this after. But
Roger versus
we
clouds.
yeah, we actually have a project doing deforestation in Liberia, like detecting for illegal deforestation, and it's quite a cool project, and it's very motivating to work on. But 6 months out of the year, the whole place is covered by clouds, and we're using satellite imagery. So there's 6 months out of the year where we're just like stuck, and we're like, oh shit, well, we can't do anything. But yeah.
Bad time to have a contract.
Yeah. Well, it's for the whole year, so at least they got half the year out of it.
There you go.
What was I just saying? Yeah, the data stuff. Yeah, so yeah, there are actually a ton of new satellite data sources popping up. And not only are they increasing in coverage, but also in frequency. So how much time it takes to pass over the same point, because the satellite's always rotating around the world. And it's the main hurdle right now that we have to deal with is cost. So there, for example, if you want to buy like 50 square kilometer region of imagery at like 30 centimeter or 50 centimeter resolution. So that's every pixel you see in your image is a 50 by 50 centimeter square block on land. And side note, 30 is actually the max that you can get legally internationally with satellites. They do have higher resolution, but it's blocked by internationally. It's only used in the military. Yeah. So yeah, for this 50 square kilometer chunk of land though, at say 30 or 50 centimeter resolution, it might cost you almost like $1,500 for that one image. Jeez. So that's really the major, and we do see the prices slowly decreasing, but very, very slowly. And part of the issue is that right now the major, like, of the people who are buying satellite imagery, 50% is defense. Like, still more than that. Like, and the thing about defense is that it's always government funded, and they got tons of funding, and they're willing to pay that like $2,000 per image price. And that means that when when other people who want to use image for positive, I say positive, my own bias, but for positive reasons, then and then they're an NGO trying to combat climate change, and NGOs don't have that much money compared to the defense, the U.S. Defense Department. The satellite company has no incentive to really sell these images at a much lower price. So it's a bit of a battle that we're struggling with, and we're hoping that by creating this platform, we start to make providers, satellite imaging providers, realize that there are actually a ton of use cases outside defense that people do want, can do good. And hopefully at some point, the number of these use cases is so much that the amount that they could make off of that, if they set the price lower, would exceed the amount that defense is willing to pay. And once you get to that critical point, then all of a sudden all the doors open, and machine learning and aerial satellite imagery can be used for good, positive change.
And the key is to have high quality, high resolution images, right? Not just only Google image high level stuff, because you're trying to identify objects and cracks and pavements and in the details of things, right? So that's the key, right? High resolution images.
It quite depends on your use case, certainly. Like, there are some things you can get away with for lower imagery, but there's a lot less you can do, surely. Say like at like 1 or 2 meter resolution imagery, you can do things like overall land use, So if you're just mapping out like, the regions that are forested areas, for example, you're trying to figure out like how the forest is expanding or shrinking. You could probably do that using low-res imagery. In fact, this deforestation thing I was just talking about in Liberia, that's using 10-meter resolution imagery, which is free. But you can't detect individual trees unless you get to a higher resolution. So it really depends on your use case, I guess.
So it depends on the use case, and so different resolutions, free, let's call it free to paid, or whatever, or paid to free,
low to high. Yeah, sure.
Yeah, like there's different use cases at different levels, but the interesting stuff, well, not even interesting stuff, I think just different use. It isn't necessarily, there's no importance that paid or free, right? It's really just like, what are you tracking and what are you trying to find out, right?
Yep. We do find that typically, well, if you want to talk about things like the transportation industry or like more specific vertical industries that could be willing to invest in this sort of technology or solution, they do tend to require more high resolution imagery because they're doing things like tracking like little objects or assets on the ground rather than doing like big monitoring of large areas. But the large area thing is the low resolutions can still be useful sometimes for more like global climate change type of applications, because sometimes you're looking for like things like how like land masses are changing or like biomes are changing. But at the same time, if you had the same imagery of this, like the same region with high resolution, you could still do the same thing at higher resolution that you were doing at the lower resolution, right? You just scale down the higher resolution stuff. So in the end, the higher resolution is always going to be better.
Okay, so it comes down to supply and demand, basically. If we can get more demand, more people interested in using Picterra's platform, for example, right, and actually go on to just finding it more reasons why people, normal consumers, would want to evaluate their own, local jurisdictions or local areas, and then have more use cases and demand. The idea is that would drive up the demand for the aerial images, and then drives the cost down over time. And at some point, the door opens, and then everyone can. Then it gets democratized. That essentially is the vision, right, on the business side. Right.
And that's actually happening at multiple levels, not even just like the imagery price level as well. Like, for example, right now, and this will not apply to the students, of course, but like we have like a professional plan for a license, and right now we're a bit forced to charge. We charge 10,000 a year for that. And well, if you think about like how much a SolidWorks license or MATLAB license costs, that's actually comparable. And that wasn't the original goal. We did not want to have to price things that high, but it's kind of the same problem, right? We had to go for clients, say like in the transportation industry and sectors that are willing to pay first to keep ourselves alive and get more use cases going, to like build up our credibility in some way. And at some point when that grows enough, then we can eventually, and we find more users, that means that we can eventually shrink the price and make it more accessible to everyone else. So this whole like, big to this whole like democratization effort kind of happens at multiple scales and multiple levels.
So let's now talk about the spectrum, that is the most democratized, which is basically, young people in communities, right, who don't have any money, right, don't don't even know the skill sets of machine learning, right, and deep learning, and how they can get their hands on it, right? So we have a project together, right, with for students to solve, and I'm just going to state it just so we have it kind of written out. Let's go deeper into it. So use the Picterra platform to develop a machine learning based solution that uses aerial, satellite, or drone imagery to support the climate action plan of your city, county, or region. Now we've been kind of going through a process of iterating on this particular scope, but we've landed on using Picterra, understanding machine learning, using aerial, satellite, drone imagery as data points, and then, doing it in your own local county or region, right, with the kind of, the problems, right, of a climate action plan, right? So tell us about how Picterra would look at this scope and what value you see in this particular scope.
Well, so I suppose that one of the, as I said before, a lot of like right now, Picterra, like we ourselves are targeting more like the transportation industry and things like that. But at the same time, our ideal vision is to have the platform be used for use cases that don't only provide productivity in these kind of sectors, but also produce positive change in areas that need help. And for me in particular, I think climate change is one of those major groups of problems that we need to solve, and one that the combination of machine learning and geospatial imagery really has the potential to help with. Um, and so I guess what we're really looking for is to sort of, because this whole machine learning on geospatial imagery thing is kind of sort of a new thing, to be honest. It isn't really that well known or that well explored, and that's a bit why we're excited about this opportunity with PilotCity, is because having the perspective of a new generation of students on what solutions that they can create for their local county or city or region, I think there's a lot of value there, not only in the actual solution, but even just in the whole brainstorming, the thought process of, how can we help by using these technologies, and to do something productive for our communities. Um, and so for us, like that, there's only 15 of us, so we're a small company, and don't have time to really validate every single use case on our own. And so really the best way to discover them is to have people discover their own local use cases, and then we can see like, oh, our platform can actually be used for this as well. That's amazing. Now we can spread it to other communities that could benefit from the same solution that this student came up with from this PilotCity program. And so that's really sort of the end goal here, is to be able to take one of the student solutions and then really like build off of that and spread it to other communities, to start creating more of this positive change.
And it's enabled the young people ideally, and the people who are using the platform to also be entrepreneurial with it, right? To be able to actually, take off and run with their own services and consultancies and, products and whatnot that use the Picterra's engine, right? So that there's more
Absolutely.
hands
Yeah.
on deck, right, to
hmm
do some of this work.
Yeah, and I think in the product description we talked about like helping your county or community or whatever with this climate action plan. But like if it turns out that you came up with a great idea and the community is the township is not ready to implement that with you, like you can go on and take off with it on your own, and create your own solution, or create your own business around it if you want to. It's really up to you.
Yeah, and another thing too is that not to intend to kind of alter this, because I think it gives that specificity and that urban level use case, right, around sustainability.
hmm
But if you, I would say that it's also valid for students to go out and just start going to go to South America and start looking at images of the Amazon forest and seeing what's over there, and
Yeah,
finding solutions over on that front, right?
yeah, absolutely. And that we did say like your local county or city, but yeah, as you just said, like if you manage to, we were just talking about the limitations of finding imagery, right? And so there are free sources out there and you can find them, but maybe you don't find exactly what you want for your use case. I think the key thing here is to not be limited to images just over your region. You could find images in a different region that you could do a proof of concept over, and then that could be applied to your local county, as if you had imagery for your county, for example. So
Yeah.
and yeah, and as you said, like if you do find something compelling over like the Amazon rainforest that doesn't have anything to do with your local county at all, then like obviously feel free to pursue that as well. The urban thing is more of a suggestion, right, to get you started. But
So let's go into that just a bit more. So like, what are things that what are in regards to say the looking at a local climate action plan, right, whether it be city or county based, right, and identifying key things that address sustainability goals of that city or county or jurisdiction, right, and they go into it, right, and they're discovering all the different kind of items that they want to work on. What has Picterra um, what does Picterra know already? Like, what are some priority things that you already know that aren't that interesting to you all because you already kind of looked into, or your platform users have discovered some stuff around it? What are some of the gaps, right, that students can actually focus on as it relates to climate action, into sustainability goals in your local jurisdictions, right? Like, what has been effective, what has not been effective, what's the cautionary tale, what things are still great opportunities. Give students a kind of an approach, like what to not even spend their time on, and things maybe to spend your time on to discover more of, right?
Mm. Um, so there's multiple aspects to this, I guess. So first of all, in terms of the use cases themselves, I feel like really the sky is the limit here, especially because like we've done a few climate related projects. So there's the deforestation thing. As I said, like if avoid places that are too cloudy because that's going to be an issue. Make sure you know that the data is of high enough quality for like look at the data first, like visually, and see if you can see the object in the image or whatever you're looking for, and if you can, then that's a good use case basically for the platform. Um, and yeah, there's also the slurry tanks thing I mentioned in Denmark, where they're detecting for open slurry tanks on farms because they're emitting toxic gases. Um, Really, there's a huge variety of different things that you can try. So I would say that like I wouldn't say there's too many pitfalls per se. It's really a very exploratory task. So it's really about, I would imagine like in the initial phases of the project, you would spend some time going through imagery and just trying to see what works. And that's one of the beauties of the Picterra platform, is that to train a model, it's not going to take, it'll take you like a few minutes just to get your first model running once you know how to do it, and you can really explore to see what works and what doesn't work very, very quickly. And so we don't have all the answers of what works best on our platform. And that's one of the whole things behind deep learning, is that it tries to adapt to whatever data you provided. So I would say that the best thing to do is that come up with an idea, come up with something that that you can like draw or annotate or you can detect. It could be either an object or like a mapping, like a segmentation. So that means like land use, or like imagine the interaction as like you want to like paint over a certain region to map it out or something with a paintbrush. So brainstorm stuff, gather some imagery, and just iterate, try things out on the platform. It's not going to waste a whole bunch of time. Once you see something that starts to work, that looks like it's a bit promising, then I would say invest more into that particular solution.
Okay, so basically, okay, so let's talk about data. Let's talk about data then, okay, and where to get imagery, because this is an issue still, but there are sources, right? So when we're talking about a scope like this, climate action plan, local city, local county, region, and just an urban area that has governments, and governments might have data, or maybe there's Google Maps, maybe. So where are the top sources that students can get access to data, and how would you imagine them kind of going upon that? Do you need a moment to cough it out?
Yeah, just give me.
Sure, go for it.
I should have brought water here.
You can go get some if you want. I can go into the restroom and we just let the audience wait.
Nah, it's all right. That's all right. I coughed it out
Okay,
already.
go for it.
So
a satellite imagery, like sources, like what is the first place to go to?
So there are. So I'll start with the. So there are multiple different ones at different resolutions, and in fact, in the resources that you asked me to fill out earlier, I sent a link to some free sources already. For example, there's one that's a free 1 meter resolution map over the entire U.S. And so it's not necessarily ultra up to date, but maybe it's like a couple years old, but it does cover the entire region. And as I said before, like you don't have necessarily have to do something that like is representative of your current region and your current time. If you manage to provide a proof of concept over like more outdated imagery over a different region, for example, then that's the first step to go for before you start to think about investing in more expensive imagery that is up to date and is over your region, right? So that's one good source there. If you're looking for more like land use global stuff, there's the Sentinel imagery, which is also free. It's 10-meter imagery, so it's quite low resolution. But this is the one that we did our deforestation project on in Liberia. So it does have its uses, like for like major geographical or biome mapping type of stuff. It works quite well. There are also, sometimes you can find free drone imagery. There's this one source called Open Aerial Map. I should link to that as well. Where basically it's a repository of like free drone images, and you can kind of just browse around and look for an image that kind of suits your project. Yeah, there's a ton of different other ones called like WMS servers. So WMS stands for Web Map Service, and it's basically like a Google Maps like service, where essentially this 1 meter national map is actually exactly this. Essentially, you plug in like some server like a name, basically like the URL, some settings, and then basically you can sort of browse over a region, Google Maps style, look for somewhere where there's imagery, draw the area you want to extract, and then import that as an image in your project that you can use. So nice. That's what that, yeah. And so we have, there's a lot of different cities have free WMS sources. So that actually helps with the whole urban use case thing. I know a lot of European cities do, for example. Yeah, there's probably a bunch of US ones that do too, but we just happen to know of the European ones because we're here in Europe, Right. But for example, you mentioned Hayward. Hayward's a great example. They have pretty high resolution. I think it's 25 centimeter satellite imagery, which is as high as you can get with satellites over the entire city. So okay. That's, yeah. And I bet there are more, but that's something that like, students can ask us, and then there are places you can go to like see if there's a free WMS data source there. And then we can kind of link them to the right resources if necessary.
Okay. So would you say that there would be sources, like there's a lot of cities who have general open source data? I don't necessarily see a lot of aerial images, open data sets, in those open data portals of city governments or county governments, but some might. So do you see that becoming a source? I haven't really looked at it myself.
It's well, I mean, so we're talking about Hayward, right? So
we're talking about jurisdictions all around the Bay Area. Yeah. So we're not limited to Hayward. No. Yeah. I'm talking about in general, like in the Bay Area, like Bay Area cities, for example.
I feel like there's potential for there to be more aerial information than drone information, just because I know in the US there's quite a few more. There's a lot of drone regulations.
Yeah.
Yeah. So aerial could be a thing. Satellite could also be a thing. Like sometimes cities will make high resolution satellite imagery available for free. Like normally you would have to pay a lot for it, but some cities will make that for free, which could be a good alternative as well. Okay. But it really depends on the city. So I can't see off the top of my head, which ones are more likely to have them or not. Okay. It's something that needs to be looked into.
So I guess my question would be, I guess, well, first of all, everything you just provide, like the sources for the aerial images, that sounds pretty promising, especially the one that has the one across the entire US and having images across every piece of land. Like that's pretty intense, right? Like that's a really great resource, if I'm getting that correct.
Yeah.
And then all the other sources you're mentioning sounds pretty promising too, right? So my only concern is that well, first of all, it'll be there for students to look at because you have resources on there already. But say they for some reason run into some bottlenecks or some issues, as they do their research or getting across and whatnot. I guess when in doubt, you can always go to Google Maps, right, and figure out what you can do there as well, right, as like a worst come to worst plan Z type of thing, right?
Yeah, That's true. Yeah, Google Maps does have high resolution imagery. Yeah, we don't directly support that in our platform just because we're not allowed to host Google Maps imagery. But some people have just taken screenshots of Google Maps and then just uploaded it just as a proof of concept. So that is an option that you can work with.
Great. Yeah, that's what I figured. And these would be all considered as kind of research purposes, right? So
Yeah,
it's a school project essentially,
yeah,
right?
should be okay. Yeah. Funny
All right.
side note actually.
Yeah.
And this is not related to Earth observation imagery at all, but the Picterra platform also works with any imagery that you put into it. So
Oh,
it's built for
good to
Earth
know.
observation. Yeah, you can, like, I don't know, put a picture of jelly beans and count the jelly beans if you want to. It'll work fine for that. But like the main difference between Earth
Huh.
observation imagery and regular imagery is just that Earth observation imagery tends to be at a very high scale. So like oftentimes it'll be like, normally you take a picture of something and it's like a 1,000 pixels by like 800 pixels or something. Yeah, sometimes you get like images that are like 100,000 by 100,000 pixels, and that's when a lot of it becomes tricky to deal with that kind of imagery. Just processing all that at scale. And so our platform is built to do processing and visualization at scale. Um, but if you can do the 100,000 by 100,000 image, then you can also process the 800 by
Jelly
800
beans.
image. Just jelly,
Yeah.
exactly. So fun side note, if somehow you found an interesting use case that could also incorporate non-geospatial imagery, then I would say just give it a shot and see
I
see
think
what
now you
happens.
just inspired a lot of students to just go have fun and
You can
figure
we had
out
one
stuff in their house.
we
So
had one student who just wanted to count the number of teeth he had in his mouth, and he just like put on a big smile and started counting teeth. I was like, okay, do what you want.
must have a lot of gaps in those teeth now to identify individually.
Our algorithm actually separates the individual teeth
Yeah, because you can
using
identify
culture.
the crack too, right?
That's
And
right.
train on the crack side. Yeah.
That's right.
So
Yeah.
that's phenomenal. That I think that you get again. I think I'm going to start playing with that now too. Now that I know that there's a reliable source to kind of do it with. So what are the opportunities of sustainability goals, right? And having Picterra solve those, and if you could dive in a little bit on urban use cases or urban potentials, that'd be also helpful. But in general, what are opportunities with Picterra on a high level around sustainability goals, and then eventually kind of urban as well?
You're referring to opportunities as in like what like benefits you see.
Yeah, how can Picterra be used for sustainability goals? Essentially, what are
Okay,
the opportunities there? What can students be inspired by to identify their? Because it's a big problem, right?
it is a big
So
problem, yeah,
yeah.
and definitely some of it will be down to brainstorming and research. But I can certainly give list a few ideas just to get the juices flowing a little bit.
Okay.
So one thing could be like doing something with green spaces. Obviously, that's a major way to fight climate change, is to understand where all the green spaces are, how they're developing, where could you put more green spaces. Urban rooftop farming, for example, is becoming a major thing.
Mm.
And especially removing reliance from these major like mega farms and all that, and having more local produce grown that can not only help with pollution, but also reduce the need to transport food around, and also cut out that I mean, about this whole thing about a lot of American farms, they ditch like 30% of the crops they grow just because they don't look aesthetically pleasing.
Mm.
So like things like these, there's so many major problems with the way that like the US system works that could be solved if things are brought down to a more localized level, where there's more transparency. Because like right now, like I don't know, I talk about food because that's a huge one. Like people don't really know where their food comes from, but if they knew the whole chain, like from start to finish, they would see like where all the waste is happening, and they would want to like cut it out. Like most people don't actually care that their apple looks like a
Mm.
beautiful shiny thing. Like it's an apple, it tastes good. It's more of like a
Mm.
marketing thing or something, right? Uh, so I think
Yes.
the whole
And,
bring everything
and
to a local level
to
is very important. Sorry, go ahead.
to dive into just the orange and the apple thing real quick, right? Like even if a student, I'm assuming, wants to like prototype identification of bad apples in a batch of apple farm in an apple farm, right? I guess they could plug in, maybe you don't have access through their local city for apple farm, right? But they can look up a picture of apples with bad apples in it and just do, ID on those things, right? And that
That
becomes a prototype for whoever needs that solution, right? So I'm
that's
assuming they can
that's
do a prototype example with things like that, right?
that's totally true. Yeah, yeah.
Okay. Just wanted to clarify that, just to give ideas to students as you're saying these use cases.
Yeah, definitely. Yeah. Yeah, and this is actually, I think it's good that we're talking about the non-geospatial use case, because we are aware that it's sometimes hard to get the right imagery. I mean, we even have sometimes difficulty finding some of our clients' right imagery. We spend quite some time finding them exactly what they need for their use case. So yeah, I think it's good that we're opening the door a bit to other forms of imagery, and also to open the door a bit more. Uh, I want to mention that we have this Docker thing. But I can get into that afterwards.
Okay,
Once we finish
sure.
talking about the
Nice, yeah.
the sustainability aspect of things.
Sure.
So besides green spaces, other thing you could monitor are things like traffic, for example. You could figure out how big an industrial area is growing, or how much pollution is being caused. Like, you don't, measuring emission in itself is tough, because measuring emissions means that you have to find a sensor that can measure like various gases in the atmosphere, and with RGB image, usually you're not going to see it that clearly. But you can always measure pollution indirectly as well. You can find ways that are markers or cues for determining how much pollution the city or region is generating, by how much traffic there is, or how many factories there are in a region, what are the hot spots, that kind of thing. Maybe identifying like residential areas that are near, or like areas that you can maybe grow more trees in near the factories to help suck up some of the carbon dioxide they're producing. That kind of thing. It's really quite freeform, I would say. But yeah, if you think about things around like emissions and toxic gases, that's definitely one way to go. You could also do things like how biodiversity is also a big thing. So if you had access to, I don't know, say if you had a drone and you were allowed to fly your drone around people's lawns, and to take a picture of their lawns and see like how biodiverse their lawns are. Now, I know in the US people love their like perfectly green cut lawns and everything, but and maybe that's changing
Yeah,
nowadays.
it might be changed. I don't think people have lawns really anymore, but yeah.
Well, so one thing that in the Switzerland that people still have lawns here, but people are actually ripping out their like perfectly trimmed grass lawns here, and they're starting to plant more like diverse like herbs and weeds that are growing like different. It doesn't look as clean, but you're introducing tons of biodiversity and richness to the soil, and that helps the environment in so many other different ways. And so, if I were to do a project in Switzerland measuring biodiversity, I would want to like say fly a drone over all these different lawns and measure how biodiversity is changing, see which lawns are not biodiverse that could use it, and then maybe suggest, like going over them, being like, hey, your lawn could be much better and more biodiverse. Why don't you read this information about how biodiversity helps the environment, and maybe you can change your mind about it, that kind of thing.
Yeah, a student can almost like, get just somehow identify all the lawns in a city or whatnot as an example, and then they're processing how many lawns there are there, just so they can at least have a count. Like that alone is really valuable, right? Even have a count of how many lawns there are, right?
Absolutely.
And then identify, how many of them can be, if that one lawn, right, was swapped into a biodiverse lawn, and then they were scale it across all these homes as a program, right? And give literally like flyers, say, hey, change your lawn, to this, and you save X. Now cities can advance their climate action plan. That's one example, right?
Actually, one of my friends is doing something similar here. He said he would actually get a subscription to the platform to do it. So he won this little local climate project. And basically what they're doing is something kind of similar, but more applied to solar panels. And the idea is that he wants to take rooftops that have a potential to have solar panels on them. So basically just empty rooftops with enough space. And the idea is that once he figures out which ones could have solar panels, he would basically go to him and his group would go to each of these people and hook them up with people who do have solar panels to help make the process of adding solar panels to your rooftop much easier. Because there's a lot of paperwork and a lot of difficulties with getting solar panels on your rooftop here, a lot of legislation to work through, etc. But if you know someone who's already done it, that process becomes much easier. It becomes less of a barrier. And so the first step is to figure out who has the solar panels, who's been through that whole process, and who doesn't have a solar panel and could benefit from the experience of those others. And so that's definitely one application of the platform, is just figuring that out, those two groups of houses.
Yeah, it's almost like a pre-qualification process for solar panel placement, right? Or you know, so there is this kind of huge use case of like it's almost like Picterra's platform is being used to essentially pre-qualify opportunities, right? And then it can be delivered to the people who are delivering services and programs to then be able to actually engage those local entities, whether it be a house, whether it be a park, whether it be a city, whether it be, you know, a neighborhood, whether it be, you know, the people who own that land, basically, right? To say,
absolutely.
hey, we have an opportunity that we've pre-qualified you for, or we have an idea for after doing some assessment, right? Using this platform called Picterra, right?
Yep, exactly.
Okay.
That's actually, I think that's something that's quite because essentially at the end of the day, all the platform is doing is detecting stuff on images. The ways you can use it are really limitless, you know.
And what are some, so I didn't ask you this question, you know, what does it actually give you? What can it give you in terms of information and data? So say you were to pump in a bunch of jelly beans, right? Does it do how many jelly beans? Does it tell you the color? Does it tell you, you know, what kind of data do you pop out, you know, as actual data that's insightable, right? Or it has
Okay,
insights
so
on?
let's take the jelly bean example then. So you can definitely produce the count of the jelly beans. You can also produce the amount of area, the number of say you know the amount of area the jelly beans takes up on your table, for example. You could also go one step further. You could build a detector that only counts red jelly beans, and you could count the number of red jelly beans in the area that those takes up, or only the blue ones, or whatever. Or say the jelly beans are different sizes for some reason. You could also filter by size and only find the jelly beans that are of a certain size. And at the end of the day, what ends up being the output is you get this there's a file format called GeoJSON, but in essence, it's just like a vector file format. It's just like a file format that stores shapes at certain locations.
What's it called again?
It's a GeoJSON.
GeoJSON, got it.
Yeah, or a shape file. Yeah, it's basically like a file that stores geometries or polygons, essentially. And so that's another important point I wanted to bring up, is that once you have this GeoJSON file, so like this, you know, basically like polygon drawings of all your jelly beans, you can use that information outside of Picterra as well in other applications. Like say your solution doesn't involve just detecting stuff, right? Say you want to like, you know, use detections as an input to another application that you are writing. You can totally do that. In fact, we have an API, so you know you train a detector on our platform, and then you have, if you have another application, you can call the detector using our API. It generates detections. You feed those results into your own application that then does something else with the jelly beans. You know, like it could be like a program. This is a stupid use case for, I don't know, like say it counts, your program just takes the jelly beans and then it goes through the lists of jelly bean count guesses for all the people who tried to guess the number of jelly beans, and it finds the one with the closest match of jelly beans and sends them an email, you know. But say you were,
you can create an entire workflow, basically.
Yeah, absolutely. Yep. Definitely. And that's a bit the first step. Yeah, so you can definitely do that via the API. We're also working on something called blocks, which are essentially like creating a workflow, but inside our application. So like you would just run it directly on the platform. Essentially, it's the same thing as using the API, except that you're putting the blocks on the platform itself, so you can keep everything in one place and run it end to end directly on our app. The other cool thing about that is that if, say, another student group creates a block of functionality inside your workflow that does one specific thing, like say the block, I don't know, the block like filters your jelly beans by size or something. You know, it takes all the shapes of the jelly beans and chooses the ones that are exactly a certain size, and that's what the block does. Say another team wanted to do something with jelly beans and that size jelly beans as well. You know, they could take your block, plug it into their workflow, and use it in their own project as well. So the blocks allow sort of this like whole sharing aspect of functionality that normally the API, well, you can share stuff via the API just by copy pasting code to somebody else over email, but the blocks is a kind of a more like built-in way to do that on our platform.
So I completely forgot about the API and the block development as well. So we should dive into that briefly as well.
Yeah.
So the API does what? And then let's go in. Well, share with us what the API does, and then let's go into the block right afterwards.
Okay. So the API, so on a platform, first of all, your workflow on the platform looks something like upload your image, train your detector on that image, run detections on that image, export the results from the detections. That's kind of like the simplified version of those steps. So with the API, the only thing that you actually ever really need to do directly on the platform is the training part, because that requires drawing stuff directly on our platform. But otherwise, if you want to, you could have a whole workflow in your own application where you upload stuff directly to the Picterra servers via the API, like upload the images, and then run once you have a trained detector on our platform, you could directly run via the API the detector in your own program and then export the results. And so that lets you basically get most of the functionality out of the Picterra platform, but in your own software product. Okay. And we have a lot of customers, especially our bigger customers. They tend to have their own like workflows in their companies, so they always opt for this approach because they always want to do something using the detections outside of the platform. Funny example, one of our clients is basically they manufacture car parts, and normally they have this big belt of different car parts, and the parts are kind of like, sometimes they're L-shaped and sometimes they're like straight and sometimes they're square. And normally they have they have like workers trying to like filter them out and sort through them and figure out which one goes which, and doing a quality assessments on these parts. And basically they want a way to automate that. And so, now they basically just have a bunch of phones on top of the conveyor belts that are taking pictures of these car parts, and then using the phones are using the API to run the detectors on the different shapes of the car parts to identify how many of each part there is automatically, and whether or not they're like missing a screw or something.
That's definitely not a fully aerial image, but
it is not. It is top down kind of, but
yeah, it is top down.
Yeah. So another interesting
cool
example.
So that's helpful to know that the API essentially can be embodied into someone else's application and actually run the same functions, right, of training in an image, right, to then export a result essentially.
Yes. Yeah.
Great.
Basically.
And then when the block detection is very interesting, because you can now essentially create you can decide what type of furry cat you want to identify, right? Or to go even deeper than that to identify more advanced use cases. So explain what the block is and how they could even, give us maybe even an example, if you can, around sustainability on it. But just give us a little baseline first on the block and what it can actually do.
So the block is basically an isolated chunk of functionality, and it's quite a simple thing. It basically has an input and an output, and in between there's something. And going back to the deep learning analogy, the something could be a deep learning model that learns to take an image and identify whether it's a cat or a dog. And so in our case, you could think of the green space detector that you built on our platform as one of these blocks, right? You take an image, which is an input, and you output the green spaces. However, you could take that one step further and say you want to do something extra with that. Say you wanted to take all the green spaces and now classify those green spaces as to like whether or not they have trees on them or something, or filter them by size or separate them. Now you need a new chunk of functionality that can do that. And so this is a bit what we realized is that at first all we had on our platform was the detector, but then we realized that there's so many possibilities for other things that you could do on this imagery besides just finding raw detections. And so the blocks were our solution to this. Basically, the way they work is that they're kind of like I don't know if people know like Jupyter notebooks, but they're essentially like they're like an empty code space, and you can write code in Python. So for now, that you can basically takes in an input, which could be an image, it could be this GeoJSON file, it could be a text file, whatever you want, and then it outputs something else that you also define. And that's yeah, it's basically just completely free form. And the idea is just that like it's like a Lego brick, like it's good for something. It can be used for other things as well, right?
Yep.
So I don't know, like what
Yeah,
our favorite.
and that's a perfect description of it. And I'll try to reiterate essentially. So say a student wanted to create a block of a lawn that has trees on it, right? And then they want to identify a block that has, or create a block that is just a lawn, right, with no trees on it, right? So
Right.
lawn with trees, lawn with no trees, right? You can actually develop a block that identifies that if there's a shadow or a tree on it that kind of blocks off, like a circular thing that blocks off the lawn, and then that's what it's detecting, right, all day long. And also is detecting unobstructed lawns, right? And then you can even take both those blocks and say, hey, detector, detect which one is either or the blocks, right? And then essentially can identify which one has a block, this block with trees on it, ones that don't have blocks. Am I getting that correct?
That's definitely yeah, you can definitely do that with blocks. That's a certain possibility. I guess I wouldn't think of blocks only as finding things though. They could also be a way to like post process your results. So one example is, so let's take this example here. So you could take a block that finds all the lawns, and then next to that block, you chain a block that takes your lawn detections and then separates the detections, that separates those results into either the ones with trees and then the ones without trees. But I wouldn't say that the ones with trees and without trees, like those aren't blocks in themselves. Those are just results that are coming out of the block. The block itself is the piece of functionality that's doing the separating of the previous results. So it's yeah, less about the results themselves and more about the functionality that produces the results.
Got it. So a block essentially is a method or a functionality to actually do the processing. It is a post-processing mechanism to deliver the exports and the results, essentially.
Yep, exactly. And yeah, it could be as complicated as like a simple like vector operation, just like simplifying some geometries. It could also just be an entirely different machine learning model in itself if you want to explore like, using PyTorch to do something.
That's very exciting. So we're encouraging students to use the block to code their own blocks, essentially, right? To go as far as they can, right, into the deep learning model, essentially, right? So have aerial images, train it to detect particular objects that solve that helps advance the conversation around climate action, and then even go to the extent that once you get into the detection, right, maybe there's a variety of different things. There's a variety of contexts, let's call it, right, that object has in the community or in the aerial image, right? And it may need a block development, right, to essentially post-process those images to have a better, cleaner data set for an export to then share as insights.
Exactly.
Right? And then maybe the API can be folded into that afterwards in case they want to build their own app to deliver their own services to a community eventually.
Right, if they want to integrate into their own like a local system or something, that's when the API would come in.
Right.
Yeah, actually, so another cool example would be like for buildings, we have one block that once you find all the buildings, typically the results tend to be a bit like, say a building is like a nice L shape, with machine learning models, they're notoriously bad for producing output that's a bit like, you kind of see the L shape, but it's a bit fuzzy. So we actually have a block that takes that result and then converts the geometries into something more clean and L-shaped like. And if you have that block, then someone else can build a detector for buildings in a different city or like a different part of the world, and then use that same block to clean up the results afterwards. But it's the same block, but used in two different use cases, essentially.
Okay. So essentially, it's at the end of the day, it becomes a chisel, a tool belt. It's something that allows for someone to actually be able to kind of hammer away or iron out, or or evaluate or magnify or microscope right into the aerial image and create their own custom functionality to get what they actually need from the actual data. Right?
Yes, exactly. And that's a bit, I think, the tricky thing when you're coming up with what problem you want to work on, is that I don't want to say limit yourselves to something that forces you to use a block, because you're kind of making your problem. I would say first come up with a problem you want to solve, and then see whether or not it fits into Picterra, because basically we're all about flexibility. As long as the problem you're solving can involve imagery and machine learning, then figure that out first, and then see what you can do on the platform to make it work.
Yeah, or you can go do what Roger just said, right? And in addition, if you want to play with the block development because you want to have fun and just learn more about the Picterra platform, so you can use it for other use cases, you can find something, I'm sure, right, to help clean up the image that doesn't need a block development, but you may want to just play with it just to make the edges all clean, right? Like that.
That's right. That's right.
So you can do that too, maybe if you want to just have fun with it. So I'd like to cap it with the thing you mentioned around Docker. So you're saying, is there a repo somewhere that someone could download Docker and just run a repo, like some example or something like that? Elaborate on your Docker resource you're talking about.
Docker. So the Docker thing is actually a way. It kind of goes into this using our solution offline kind of thing. So basically, once you train a detector, you can basically export that detector as a Docker image, and essentially it lets you run that detector locally on your computer if you have the hardware. It's basically just a way of saying that if you don't want to rely on our Google Cloud servers, you can, So it's more of like a data privacy thing. It probably doesn't relate as much to this particular thing. And in terms of examples, though, we have a lot of resources that new users on the platform can try out to figure out what the platform is doing and how it works. We have a whole Picterra University, which is a whole series of online courses they can take to really figure. It goes through each of the pieces of functionality on the platform and instructs you on how to use them. We also have once you first log in, there's a bunch of example projects they can immediately import and train and look at results on to see what kind of output the platform produces. So yeah, there's definitely. We also have a Slack community, which you're more than welcome to join and talk to us about. Yeah, we're more than willing to chat with you on Slack if you have questions. So yeah.
So all the resource that you just mentioned, we'll get that from Roger, put that into the research and train component of the program. So everything he's talking about, you'll see eventually in the program. So, well, Roger, this has been our longest podcast actually, and I would say I actually really even really enjoyed it as well. We typically cap this to an hour, but there's just way too many good stuff in there, from your personal journey, right, to Picterra itself and the vision and mission, to the project itself and the use cases and the opportunities around that. So this is really great. We just have less time for you to do the vlogs now. So you may have to spill over and have some homework.
No, that's all right. I think it's better for me to do them asynchronously. Oh, connection.
Yeah, and
sorry, it got kind of laggy right there.
It did get a little laggy. This I think this video alone that we just did also has provided so much context, right? That I think it's gonna be super beneficial. for
Okay,
students.
great. Well, I had fun
So
talking about it too. I'm always so like in the zone with working that sometimes I lose the context I'm working on. So it's good to for myself as well, just to talk about it a bit and really get my
yeah, for
get some
sure.
of that passion back.
The beauty of long form conversation, right? Be able to dive in a bit deeper than what we typically have time for.
Yeah.
So any last particular, shout outs or things that, you want to tell students just to kind of cap it off? Any particular things on top of your mind?
Um, I think the main thing is just like keep an open mind. It's we want you to be like motivated in the project that you're doing, like especially for me, I think of like climate change as one of the for me the top issue that needs to be solved in our generation. And there's so many ways to solve it. I just encourage students to really think outside the box. Like fighting climate change, geospatial imagery, machine learning, all these things are like relatively new things that we're dealing with. And so there's so much potential for new ideas to come out. So really, like, don't just think of like the classic few that everyone likes to talk, like the buzzwords. Try to like think of things that could help solve the problem, even if indirectly. I think there's a lot of potential there. I can't tell you exactly what those solutions are, because if I had all the answers, I'd be implementing all of them myself already right now. So it's really up to you guys to help save the world, essentially.
All right, well, let's cap it there.
Yeah.
Save the world.
Yes.
Thank you, Roger. We look forward to having Picterra be part of the program again. And we have a lot of opportunities for the students to build on. And I think this has been really clear and elaborate and exciting. So thanks for your time. And we'll hold you back